This is my final project for computer systems and architectures. I decided to program a network-based server and then client for the game of Go. Essentially, Go in a nutshell. Each player takes turns placing pieces on a gridded board. If you fully surround your opponent's pieces, you capture them, and the goal is to build up as much territory that you control and capture as many of your opponents as you can. Um, so the programming language I chose to use was Rust. It is a system-based programming language, so it has all of the speed and low-level features of something like C with lots of type safety built in. Um, as far as challenges, the biggest challenge I ran into was just because Rust is so strict about memory safety when it came to things like the TCP connection. It could only really exist in one place at one time. You could not, for example, have a reference to that and use it elsewhere. So what I did was implemented a concept called an actor. Essentially, the way that works, there's a structure called a client actor that holds the TCP stream, as well as a receiver where other parts of the program can communicate with it. So essentially, the stream to the client lives within this actor, and then it can receive a more robust kind of enum implemented in Rust, which it is essentially a message telling it what task to do. And it also, if needed, sends it a one-shot channel, which lets that actor communicate back one time with any relevant response. It is created through something called a client actor handle, which is a separate struct. So the handle is what can exist elsewhere in the program and communicate with that actor to then communicate with the client. And the reason for doing this is the actor handle can safely be cloned and utilized elsewhere throughout the program. Um, Most of the implementation here are just handling, sending, and receiving those requests. So back in the main program, to quickly go over it, it starts off by getting arguments using a library called clap. So it gives us slightly more nice looking ways to get the listening and port address, or listening address and port. And then it spawns the listener, and then it creates the vector to hold all of the client actor handles. It first creates a clone of it, sends it off to the matchmaker thread, spawns that. The matchmaker will look for pairs of players who need a matching. It will create a game if it's able to. And then from there, the main thread just listens for connections, negotiates the initial information for that player, so their name, the board size they'd like to play, and then the matchmaking thread handles the rest. The thread for matchmaking, just as I said, looks through, finds players of the same board size that need a game. Because these are mutex locked when it's accessing those handles, the matchmaking thread is not as pertinent. So what we do, we use a try lock on the mutex. And if it can't get a lock, then it sleeps for 100 milliseconds. That way it doesn't starve out the listener and can operate more smoothly. And then once it creates that game, that's its own thread, and it essentially just takes turns sending information back and forth with each player to get their play. That's the gist of the main server. And then the client, also in Rust, I wanted it to be a terminal user interface. I wanted it to be responsive to things like resizing. I used a library called crossterm, which makes this more portable across different operating systems. I tested it on both Mac OS and Linux, but it should work on Windows as well. Um, it works in a similar fashion. We start off the program by getting the arguments for the address and port of the server, and then we try to establish that connection. Once we establish the connection, we go into the main client area, and it uses a read evaluate process loop, or yeah, read eval process loop to constantly listen for input. We're using raw mode here, which basically means rather than stood in, stood out, it is just getting the input as it happens. So if a player presses up, down, left, right on their keyboard, it's immediately able to process that to move around the game grid. Um, but as far as the flow here, it first goes to the menu state, which asks the player if they need to know how to play the game, what they'd like their display name to be, what board size they'd like, and then it enters the lobby, which is just while it's waiting for the server to create a connection. And then finally, it goes into the game state. But to show this in action, let me start up the server first. And for port, sorry, for the IP, if you want it to be able to work outside of localhost, you just use 0.0.0.0, and we'll use the default port 9090. For this, we will just use localhost because we are on the same device. And if we didn't know how to play Go, it will give us the instructions. And then here you can see it's waiting for another connection. So we will repeat that here. Oh, I'm so sorry, this is the wrong folder. There we go. No, random name, same board size, and you can see we're in a game. Black player goes first, so if they were to play, it would go like that. Then you could return over here, so the other player can move around and play a piece. And just to show the capturing working, essentially, so this top left piece would be fully surrounded, so if white plays there, they capture. You see it updated. Also, just to show what I meant about resizing earlier, it can sense when the board is too small or the screen is too small. And then just to show that not only is it multi-threaded in that it can handle both players at the same time, but it also can handle multiple games at the same time. We're going to try that right here. And same one more time. Yes. And there's another game in action. And then the game continues until both players pass. Now you can see that's a game ended. You can just press Q to quit, and the server continues on forever. But that's pretty much it. Thank you.